Section 3.2, the graph of a function. In this section, we are going to revisit several of the topics that we have already covered algebraically. For example, in previous sections, we have looked at how to determine from an equation whether that equation represents a function. We've learned how to evaluate a function from its equation. We've looked at how to algebraically find the x and y intercepts of the graph of an equation. Given an equation, we know how to find the domain of certain functions. So we've done a lot of stuff algebraically, but now we're going to turn around and do the same types of things, but from a graphical perspective. So you won't have a function or equation to rely on, you will just have a picture. All right, we are going to start with the vertical line test. So the vertical line test states, a set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph and at most one point. All right, so if you think back to section 3.1, okay, we talked about what a function is, and I told you that glorious statement to remember: to be a function. I'll remind you of it. To be a function, every input must have a single output. Also, we talked about if you were given an equation, so maybe something like x squared plus y is equal to 9 versus x squared plus y squared is equal to 9. Based on an equation, if you're just looking at the equation and not the graph, you can decipher whether or not the equation represents a function. If you have a y squared present in your equation, that prevents the equation from being a function. Okay, it's okay to have the x squared, but you can't have the y squared. Okay, so that's how we discussed this topic algebraically when we talked about, whether or not something represents a function. The vertical line test is used to determine whether a graph represents a function. Okay, so again, the key to the vertical line test is that we're dealing with a function if every vertical line that intersects the graph intersects it in at most one point. Okay, so the way you're going to work this, okay, you have three graphs here. We're going to try this out on example 1. Okay, so let me quickly explain how this vertical line test works. You're going to take your graph and imagine drawing vertical lines. Vertical lines, remember, those are lines that go up and down. Okay, so if there is somewhere, at least one place where you can draw a vertical line on your graph and it intersects your graph in more than one point, then it is not a function. Okay, so that's what that yellow statement is telling you. Okay, so let's try example 1. The directions say which of the graphs are graphs of functions. Okay, so since all we have to rely on here is the picture, we're going to use the vertical line test. Okay, so for this first graph, it is a circle. Okay, all I have to do is find a location so that if I draw a vertical line, it hits my graph in more than one place. And that's really easy to do with the circle. There's actually several places to do that here. Okay, so I'm going to go ahead and draw in a vertical line. And let's see here. Here we go. If we do this, we're going to try to make this as accurate as I can. Let's try that again. Okay, so here's my vertical line. Okay, so here we go. When I draw this vertical line, it is going to intersect my circle in more than one point. Okay, so what we would conclude here is that this circle is not a function. Okay, and actually, every circle you encounter is not a function for the same reason. Okay, no matter what circle you're dealing with, you can easily draw a vertical line so that it intersects your circle in more than one point. Okay, so this is a great opportunity to understand why this vertical line test works. Okay, so What it does here, this vertical line that has intersected my circle in two different spots on the circle, this is what it has done. Remember, to be a function, every input is an x value. Every input must have a single output. Output is those are the y values, okay? So by drawing this vertical line right here, this is where we intersect on the x-axis. So this is the x value. That is the input, okay? So at that x value, we touch the circle in 1 and 2 places, okay? So this is an output. This is output number 1, or y value number 1, and this is output or y value number 2. So that vertical line has caught an input that has multiple outputs, okay? So this is not a function. Okay, so let's try part B. Okay, again, you just want to draw vertical lines. Okay, so if I try different things here, okay, so there's a vertical line. We only hit the graph one time, so let me try another one. Okay, so maybe I draw something over here. Again, I'm only going to intersect the graph in one point. I'll try another one. Okay, and you can keep doing this. But every time you draw a vertical line, because this graph is a zigzag, it's only going to intersect the graph one time, okay? So that tells you that every input does have a single output, okay? So this is a function. Okay, lastly, in part C, okay, we have this graph, and it looks a little strange, and the reason it's a little strange here is because there's two pieces, but they are not connected, okay? So this is something called a piecewise graph. The graph comes in pieces, okay? So I have piece number 1, if you can see where my cursor is, piece number 1 right here, piece number 2 right here, and the pieces are not connected, and that's okay. It's not a requirement that the pieces be connected, but that may be why it appears a little strange to you, okay? So the question here, does this graph represent a function? Okay, so again, you want to apply the vertical line test. So start drawing vertical lines. Okay, so I'm going to draw one right here. Okay, again, if I do that, this red line is only going to intersect the piecewise graph one time. Let me draw another line here. So maybe I'll draw something on this piece. Okay, again, this vertical line, this green one, is only going to intersect the graph in one place right here. Okay, so I mean, you can try other lines here. Okay, it seems like every time I draw a vertical line, the vertical line is only going to intersect the graph in one spot. Okay, so here the black graph intersects right there. Okay, however, if you look very closely, okay, look at what's going on at x equals 2. Okay, at x equals 2, if you go up here, okay, dot, 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 okay, I see a closed circle here, and then keep going up. At x equals 2, I see another closed circle, okay? So let me erase this and kind of write this out, okay? This point right here, remember, if you are dealing with a closed circle, that means you want to include the point. If you are dealing with an open circle, that means to exclude the point. So both of these pieces have this endpoint of a closed circle. So both of those points are included. So this point right here, this closed circle, the x value is 2 and the y value is 3 if you look at it carefully. This closed circle is at 2, 3. This particular closed circle also has an x value of 2, but the y value is 6, okay? So again, those two closed circles, one has coordinates 2, 3, the other has coordinates 2, 6. So what you're seeing is one input, namely x equals 2, having two different outputs, okay, 3 and 6, okay? So if you took your vertical line and you drew it precisely through x equals 2, it would hit your graph in two spots, okay? that second red vertical line goes through both of the closed circles. Okay, so you fail the vertical line test in that one location, x equals 2. Okay, as long as you fail it somewhere, it's not a function. Okay, so I'll even write this to the side. Here, x equals 2 has 2 outputs. Y equals 3 and y equals 6. Okay, so we can conclude, since we failed the vertical line test here, this is not a function. Let me rewrite that. So not a function.